This is more KSP calculations for AP Chemistry. So this time we're going to be calculating molar solubility given that we have KSP data. So we're told that the KSP value for silver sulfite is 1.5 times 10 to the negative 14th, and that we have to figure out how many moles of silver sulfite we can dissolve in water. So first off, let's just make sure that we have our stoichiometry straight. We have an x, we have a 2x, and we have another x. Now, we ignore, in terms of equilibrium, what's going on with the solid. Initially, we have 0 for both ions. We're going to be making 2x and x respectively of the silver and sulfite ions. So our final equilibrium concentrations are x, 2x, and x. KSP is going to be equal to our silver ion concentration. That should be 1 plus. Let me fix that. And our sulfite ion concentration. This is going to be squared because we have the 2 here. So we're going to have 2x, and it's going to be squared, times x, which is equal to 4x cubed. Now it's a simple algebra. We have 1.5 times 10 to the negative 14th is equal to 4x cubed. Therefore, x is going to be equal to 1.6 times 10 to the negative 5th. And since we just have a 1-to-1 ratio for the silver sulfite versus the silver ions, our concentration is going to be 1.6 times 10 to the negative 5th molar. We're going to do a second problem, calculate the solubility of barium fluoride in grams per liter. This is the exact same problem, but now we're having to take the extra step of calculating it in grams per liter. So if we take a look at what's going on in our ICE table, we're going to ignore the solid in the equilibrium expression. We start with zeros, plus x, plus 2x. So at equilibrium we have x and 2x. So we have that our KSP expression is equal to the barium ion concentration times the fluoride ion concentration squared. So this is equal to x, 2x squared. So that would be 4x cubed, which is equal to 1.7 times 10 to the negative 6th. I got that value from up here. When I solve for x, x is equal to 0.00752, and that is the molarity of the barium fluoride. Now we have to figure out how many grams that is. So this means that it's moles per liter. So what we need to do is we're going to say that we have 1 liter, which means we have 1 mole. Okay, it means, since we have 1 liter, it means we have 0.00752 moles of the barium fluoride. If we have moles, we certainly know how to get to grams. So we have 0.00752 moles of the barium fluoride. We are going to multiply that by the molar mass of barium fluoride, which is 175.33 grams per mole. which means that we can dissolve 1.31 grams of barium fluoride in 1 liter of solution with no precipitate. If we try to put in any additional barium fluoride, we will see a precipitate. All right, I have 2 additional problems for you just to see how you're doing on things. I'm not going to work these through for you, but if you get the right answer, you can pat yourself on the back.